Hey everyone, I'm Poe, your friendly data guide here at PopeyePlots. Today's episode is for water chemists, but don't worry. If you're a marine biologist, geochemist, physicist, urban planner, or just a data-loving scientist who stumbled in looking for the coffee machine, you're absolutely in the right place. Why? Because to your computer, data is just a bunch of numbers, characters, and maybe the occasional oddball symbol. Like the ones that show up when your cat walks across your keyboard. For convenience, and let's be honest so we don't scare you off with anything too wild, we'll use water quality data. It's simple, clean, and bonus. No risk of getting wet. So, whatever your field, as long as you occasionally face a mountain of recurring, tricky data, the skills we cover here, importing data, exploring it, and turning it into clear, beautiful visuals, will work for you. And hey, if you're just here because plots sounded artistic, or you thought data frames were IKEA furniture, that's cool too. So, grab your curiosity, and if you're a chemist, maybe your favorite beaker, relax, and let's dive together into the world of data analysis and visualization with Python. Ready to get started? Let's make data fun. All right, let's get to the fun part, actually working with some data. Picture this. We've got a water quality data set, and it's pretty big. Not just a few numbers scribbled on a notepad. This one has more than 3,000 rows. In fact, it has exactly 3,001 factorial. Yep, not 3,000, not 3,002. That's like collecting water samples from 3,001 different river spots or estuary stations. If you're imagining a scientist with a giant backpack and a map yelling, "Next stop," yeah, that's pretty much it. At each of these spots, the brave data collectors measured a bunch of chemical and physical parameters to see what's going on with the water. In our data, we'll be looking at things like acidity level pH, hardness, TDS, that's total dissolved solids, in case your coffee hasn't kicked in. Chloramine sulfate level conductivity talk, total organic carbon. THM, trihalomethanes. Try saying that 3 times fast. Turbidity, and most importantly, potability status. Can you drink it or should you run? Now, how do we make sense of all this info? Enter Google Colab, my favorite online Python playground. It's like a science lab in the cloud, but with zero risk of chemical spills on your laptop. If setting up new software on your computer sounds scary, or you just don't want to wait for a download, Colab's here to save your day. Just open your browser, log into Colab, and boom, you're ready to roll. But wait, what about the data? Getting it into Colab is easy. You can pull it right from your Google Drive, fetch it from your GitHub repo if you're fancy, use a Kaggle API key if you're a hardcore data head, or just do what I do. Upload it directly from your computer. Easy peasy. Now your data's ready. But before you can play with it, you need a data frame. And for that, you need pandas. Don't worry, no bears involved. Just the most popular tool for wrangling data in Python. In Colab, all you have to do is type. Import pandas as PD and hit run. If you're coding locally, you'd have to install pandas first. But Colab makes life easy. All the major libraries come pre-installed. So, what's pandas anyway? Pandas is a Python library that helps you work with data easily. Imagine you have messy tables in Excel or CSV files. Pandas can clean, organize, and analyze them with just a few lines of code. It uses 2 main tools, series, like a single column, and data frames, like a full table. With pandas, you can sort, filter, merge, and even do calculations on your data, making it a go-to tool for anyone working with data. Ready to see some data magic? Let's jump in and start exploring. First, we need to load our data. Type df equals pd.read_csv brackets, double quotes, brackets close. Remember to put the correct path to your uploaded CSV file between the quotes. Now we've successfully defined our data frame. Next, it's time to import some helpful libraries for data analysis and visualization. We'll use NumPy for calculations, Seaborn and matplotlib.pyplot for data visualization, plotly.express for interactive charts, and the warnings module so we can filter out unnecessary warnings and have a smoother workflow. With all these tools, we're ready to explore the data. Now, let's run a few basic commands on our data frame to get a preliminary understanding of the data. First, type print, open bracket, df.shape, close bracket, and press run. This will show the total number of rows and columns in your dataset. For example, you might see 3,000 rows and 10 columns. Next, type print, open bracket, df.columns, close bracket. This displays the list of column names, helping you see what each column represents in your data. Now, to get a summary of basic statistics for each column, type print, open bracket, df.describe, open and close bracket. This table provides important details, including count, which shows the number of non-null entries in each column, mean, the average value of each column, standard deviation, which measures how much the values vary within a column, minimum, showing the smallest value found. The first quartile, or 25% mark, means a quarter of the data falls below this value. The second quartile, also known as the median, shows that half the data is below this point. The third quartile means 75% of the data is below it. And finally, maximum, which is the highest value in the column. Next, type df.info, open and close bracket. This command provides a summary of your data frame. It shows the total entries, the number of columns, each column's data type, the number of non-null values in each column, and the total memory usage. This is helpful for quickly checking the overall structure of your data. If you want to find out the total number of missing or null entries in each column, type print, open bracket, df.isNull, open and close bracket, .sum, open and close bracket, close bracket. This will show you a count of null values for every column in your data. Understanding the data types in your data frame is important for any future operations. To see the data type for each column, type df.dtypes. Now, hold on. Here comes a little flashback. Python doesn't just see your data as plain numbers or boring old text. No, it's smarter than that. It classifies your data into different types, like integers for whole numbers, floats for decimals, booleans for true or false, objects or strings for text, and even some special categories like dates or factors. For example, if your columns are mostly decimal values, it will fall under floats. And the column portability status contains only zeros and ones. This column will show as integer type. That little 64 you see in float 64 or in 64 isn't random. It represents how much space Python uses to store each value. 64 means 64 bits, so the computer can handle very large numbers or very precise decimals. A float 32 uses less space and is less precise than 64. Okay, that's a wrap for now. We'll continue our learning journey in the next episode of PopeyePlots. But before you go, if you enjoyed this video, don't forget to like, share, and subscribe. Hit the notification bell so you never miss out. Until then, see ya.